There are three equations of motion with uniform acceleration, and I'm going to prove the three equations of motion right here on the board. We know that acceleration is the rate of change of velocity with time. So if I denote acceleration by A, and velocity, the change in velocity is the final velocity minus the initial velocity. So let V be the final velocity minus let U be the initial velocity over time, T. So I will make V the subject of the formula. This is over 1. Cross multiplying, I have AT is equal to 1 times V minus U, that is still V minus U. So if I take away minus U from the right to the left, it becomes plus U. That is, AT plus U is equal to V. So V is equal to U plus AT. This gives us the first equation of motion with uniform acceleration. Alright, let's prove the second formula. Average velocity is the sum of the velocities all over 2. This is 1. And also, average velocity is distance over time. These two formulas are correct for average velocity. Now, I want to equate them together. I'll get this. S over T, which is this, is equal to U plus V over what? 2. Now, this is V, U plus AT from the first equation. So I can actually say X over T is equal to U plus, in place of V, I'll write U plus AT over 2, as we have here. And so this gives us 2U plus AT over 2. So X over T is equal to 2U plus AT all over 2. So splitting this fraction at the right hand side, S over T will be equal to 2U over 2 plus half AT. So 2 cancels 2. S over T is equal to U plus half AT. So I want to make X the subject of the formula. What will I do? I will multiply both sides by T, so as to eliminate this T at the denominator in this left hand side. So X will be equal to U times T, that's UT, plus half AT times T, that's half AT squared, because T times T is T squared. And this gives us the second equation of motion with uniform acceleration. Alright, it's getting more interesting. To get the third equation of motion, what do? We'll square both sides of the first equation. So I will square both sides of the first equation of motion, which is this, V equal to U plus AT. So let's square it. V squared is equal to U plus AT all squared. That's it. So V squared is equal to, if I square U plus AT, this is what I will have. U squared plus 2UAT plus A squared T squared. You can actually work it out to see how it is gotten. So V squared is equal to U squared plus, for this last two things that I have here, I'll bring 2A out, open a bracket. Now watch. If I divide 2UAT by 2A, what we'll have left is just UT. So UT plus A squared, T squared does not have a 2. So if I must bring out a 2, I must divide it by a 2. That's what it means. So that 2, this goes inside and cancel the 2 at the denominator. Now, divide A squared T squared by A to give you AT squared. So that 2a times at squared will be 2a squared t squared. Then divided by these 2. 2 cancels 2. We now have a squared t squared as we have earlier. Now look very well. What you can see here is the second equation of motion. Ut plus, this is actually half at squared. So I can actually say v squared is equal to u squared plus 2a. Then in place of this, I can write s plus 2as. So this gives us the third equation of motion with uniform acceleration. Thank you very much for watching this video. I hope you like it. Subscribe, like, turn on notifications, tell your friends about this channel so that they too can come and feel the simplicity of mathematics right here in this academy. I'll see you in my next video.